Good morning. This is Sanjay Ranka from University of Florida. I'm a faculty in computer science. I'm also affiliated with the Institute of Aging. And today's talk is about ROAMM, a smartwatch-based software for real-time and online assessment and mobility monitoring of patients. This work is jointly done by a variety of folks, which are both part of College of Engineering as well as Aging. There are researchers from both healthcare and computer science. And here the list of some of the prominent names there, as well as the students who have helped us develop this project. The outline of my talk, I'll just broadly talk about the current state of the art, if you may, for wearables and watches. Talk a little bit about the key characteristics of the ROAMM project from mobility point of view, from health events point of view, what domains do we cover, what kind of EMAs and PROs we can measure, as well as the cognitive tests. And then I'll talk a little bit about wristwatch challenges which we face if I have time. The main goal is to cover the key characteristics of the project. Where we started was around 3 to 5 years ago. We realized that wearables are going to become an important source of patient information. In particular, wearables can collect a lot of data continuously in a passive fashion without patient intervention in there at a frequent basis, and in many cases multiple times per second. And they are very lightweight and portable. And we looked at a variety of wearables to collect this data, and then finally decided that smartwatches were the way to go because they were getting more popular, as well as the cost of them was at a level where we could use it for research studies. And in particular, the Apple and the Samsung smartwatches had a variety of sensors, and we expect that as the sensors mature, they will be incorporated because of the wider use and the lower cost thereby. The other advantage of using smartwatches is that they're continuously connected through satellites, where people can collect data from them and interact with the patients at a 24/7 basis. If you use a system which depends on Wi-Fi, then the patient has to be close to a home computer or other Wi-Fi device to be able to collect data. By using smartwatches, we can actually collect data all the time. And that's an important part of our aim and objectives. In particular, our goal was to target older adults, although much of the technology which I'm going to present today should be applicable for other age groups also. Smartwatches, as I was pointing out, are getting more popular. There are around 20 million plus, which were sold in the US last year, and the number is exponentially growing. We expect that it'll be a good medium for interaction with the patients, as well as for other users. And the other good part is that they're lightweight and easy to use, unlike accelerometers, which are run by smaller companies. They tend to be large and bulkier to use in terms of patient data collection. The interesting part, as I was discussing earlier, that they are connected all the time, and they are going to have more and more sensors in place. So what's the main goal of ROAMM, real-time online assessment and mobility monitoring project, is to be able to capture a variety of domains and to be able to assess, test, retest reliability and validity of data collected from these smartwatches so that they can be useful for healthcare measures as well as healthcare predictions. Our main thing is that there's a lot of data which gets collected when an event happens. So for example, a patient has a fall, and the patient goes to the hospital. At that juncture, they attach a variety of sensors, and they can collect a lot of data. But what happened before the event, no one really knows. And one of the advantages of having data before is we can either prevent it or at least ameliorate the event impact of an event. And the idea basically is that if there is no change IHE, then a patient will follow a trajectory where their things are only going to deteriorate slowly over age, while if an event happens and we can prevent it, they can potentially have a better trajectory than if we cannot prevent that from happening. The challenges, of course, is that the technology should be such that it can interact all the time with the watch. And that's one of the reasons we chose a cloud as the main collector of data for a variety of reasons I'll discuss in the later slides. What ROAMM does is it collects and harnesses wearable and smart devices. Although our current focus is on smartwatches, over time we expect there'll be other sensors which are going to be attached to the bodies, and they will communicate with watch as the hub, and then be able to direct to our platform other kinds of data. In particular, we expect glucose sensors and other sensors which are relevant for healthcare studies to be part of a smartwatch, and there'll be other sensors which will be then connected to the smartwatch itself. The core domains which we have focused on is community mobility. We want to understand how people are interacting or moving around in the community. That's an important part for older adults. What kind of activity patterns do they have? How much do they walk, if they run, or other exercises or other activities they do. We can collect information about patient-reported outcomes and their momentary assessments of pain and depression and things of that nature, or anxiety. We can also measure, as I'll show you, cognitive and mental health. And if an intervening health event happens, then we can call them or ask specific questions about the intervening event on a one-off basis. We're expanding it to other things. For example, we can detect by movement of a wristwatch whether you're touching your face. In times of COVID, that may be an important observation, and telling the patient that maybe touching their face after they had touched something else may not be as useful, may be detrimental in some sense. We can look at how much time they spend in vulnerable areas in terms of smoke, in terms of pollution, etc., or even look at their eating behaviors and if they are sleeping enough during the night. The end goal obviously is that to be able to create some kind of overall behavioral graph in terms of how much time they spend walking, what's their walk speed. This is a good reflection of their overall physical capabilities, and be able to generate a life space of community mobility like I've shown in the right part. How much are they traveling from their house, if you may, in the neighborhood? It could be through driving or it could be through walking. As I was discussing, one of the advantages of using a smartwatch is that it's always attached to a person unless the smartwatch is being used for charging. So we have developed a software which runs on a smartwatch. It runs both on Samsung and Apple smartwatches. And you can ask questions which are, as I will show you, configurable based on the needs of the researcher in terms of what we want to measure. So for example, we can use the watch to measure pain, fatigue levels by having them asking a question about their current pain level, and then they can dial in what level of pain they have, say for example 0 to 10, or in some cases the answer may be yes or no, and both of those kind of assessments and patient-reported outcomes can be measured. And I'll show you the instructions which we provide right now to the patients, which will give you a better idea of how the system actually works.
Before we show you how to use the watch, please remember that.
So this way, the patient can answer all the questions which are being asked, and of course, they can be modified based on the requirements of the researcher. The other thing which the ROAMM software provides is ability to measure cognitive abilities. In particular, for older adults, we want to be able to see onset of either dementia or Alzheimer's. And there are standard tests which we have modified to fit the requirements of a smartwatch. We can measure, for example, reaction time. We can ask questions about shape and ask them for a go, no go kind of executive function test, or do a digit span test for working memory where we can ask them to repeat questions in a forward fashion or repeat the digits that they hear in a backward fashion. And I'll now show you by example on how that actually works. It's kind of a flow, if you data flow where people can look and say, hey, do I want to take a memory test or not? And then the recording will keep on asking them questions accordingly. So here are some details on the instructions which we provide to the patients right now, and this is the way they interact with the watch. So this way we can actually measure their cognitive abilities over time. Of course, you can set up other periodic questions which are not at a daily basis. They can sometimes be conditional on what data you observe, or you can ask them every week or every month in terms of, hey, did you have any falls during the last week? If you had a fall, then you'll ask question, what day did it require hospitalization, for example. So these kind of these kind of questionnaires can be built in, and they can be, if you may, submitted to the patient at regular basis or participant at a regular basis, and then be able to collect that information. The important part, obviously, is that we need to be able to develop a system which can be configurable, because different researchers or different campaigns, as we call it, may require different pieces of information. So, for example, a researcher one may want to create a campaign to collect accelerometer data or user-reported outcomes on pain, and another researcher two may want to get data on GPS and user-reported outcomes on activity, depending on their needs. And then we want to be able to say, hey, I want to be able to create a campaign where I'll have 20 participants for researcher one and maybe 50 for researcher two. And the 20 ones which are part of campaign one would be asked questions based on needs of researcher one and similarly for researcher two. So we have developed a system which will allow you to configure these questions on the on a web screen and then automatically generate a campaign which will run on watches based on the requirements. So the way it works is the campaign has many different components. It may be what kind of sensor data do you want to collect. You can collect all of these different pieces of data today, and as more sensors are added, the options will increase. And for each sensor, you can configure the sampling rate, the collection frequency, and you may also want to generate new features. For example, you might want to do a fast Fourier transform of the data to get frequency-based signals, if you may, and it will do all that for you based on your requirements. There are two advantages of that. One is that if you only need sampling at a lower rate, you can save the battery and effectively extend the battery life between charges which are required. The other thing is the amount of data which gets transmitted from the watch to the cloud also reduces if you want to if you can aggregate the data. On the cognitive test, as I showed you earlier, you can have forward span, backward span, go-no-go tests, user-reported outcomes. You can define numeric prompts which have yes or no answers, or discrete prompts, and you can have many of them. You can set their frequency. You can set the questions, the different choices which you have. All of this can be done through a web-based UI, which is very simple to use, as I'll show you in a little bit. For example, in this particular case, first the user enters the username and then be able to log in and generate a new campaign from that. And then after that, you can go in and be able to look at specific details about what kind of prompts you want to use. In this case, for example, what the long question which you want to store in the UI, but the question which you want to ask on the watch may be much smaller. You can have multiple questions. You can keep on adding more and more questions and have minimum and maximum values for each of the questions defined as your requirements are. You can also set how many times a day do you want to ask that question, et cetera, et cetera. So this kind of configuration is rather quick. You can generate, as you're seeing right here, you can generate the frequency, the times during which you want to ask that question very effectively by going through these tabs and generating the campaign. We'll see through other examples right on this dashboard where you can choose discrete values like sitting, standing, walking, and the interface is smart enough to say, look, this value is too large, which is not going to fit onto the small screen size of the watch before it actually runs the campaign itself. You can figure out what kind of cognitive tests to run, at what times of the day. You can then go into, as you'll see next, look at the different sensors and which data you want to collect. And then after that, you can go and say, hey, what sampling rates do you want? And for each of them, effectively then also be able to generate some kind of measures of which are relevant to you. So this kind of approach allows you to set up a campaign very, very quickly. And then at that particular juncture, essentially you can start enrolling different watches and assigning them to different patients. But besides doing that, it will also be able to give you at a patient or an aggregate level information about how much data gets collected, what kind of data is getting collected, and what kind of features are getting evaluated on every watch for every patient. And then there's a graphical display, which you can then use to be able to display the key data which you're collecting for every patient. There are also alerts in there. For whatever reason, if a patient stops sending data or stops wearing the watch, you will get information about that. You can get their GPS activity on a Google map. You can actually plot their activities, patterns, and things of that nature, and then use it for future data mining or machine learning across a single patient or multiple patients as necessary. But this kind of visualization, both at a macro level and a micro level, as you're seeing, is very important because then you can use this data for a variety of future studies. We have an architecture, essentially where the campaign manager is the person who's the study manager, This will be a non-technical person generally who will just create a campaign as I just discussed. It'll register all the participants who are going to be assigned watches, and you'll keep track of what watch number was assigned to what participant. They can visualize the data, and all of this information, once it's set, the campaign is set up, goes to the Amazon cloud, although one can replace it by Google Cloud also, which has similar functionalities. And what happens is every watch through an Amazon API directly sends data to the cloud. This allows us for very fast scalability across hundreds, thousands of users. And then we store the data in both a relational as well as a file-based system, depending on the cost requirements. The data can be exported to the campaign manager or other registered users for that particular campaign. Now, the architecture, the way it works is that at a technical level, you collect all these pieces of information, and then you use HTTPS to send it securely to the cloud. And on the cloud, then you store it in a fashion that it can be used for retrieving data both from a raw basis as well as an aggregate basis. We've also done a variety of studies to look at the fact that whether the data collected is valid or not, because smartwatches are a new way of collecting data. There are some gold standards which have been used in the activity area in terms of accelerometers and things of that nature. We want to be able to compare against them, and we have done so. And we generally find that the watches are reasonably good in being able to collect accurate data, for example, physical activity, walk speed, excursion distance. For obviously the EMAs, we keep track of data in our studies with the patients, whether the summaries are matching with what they actually hand wrote on their own ledgers. We are also collecting a lot of data on cognition and other functionalities on the watch. So what we do is we look at a phone screen when we enroll a patient. We have multiple visits, and then we try to assess a variety of things using a set of 20 to 30 patients. We have published papers on that. And the other thing which we try to also understand is whether people like using the watch for providing this information. Based on the surveys we have done so far, we find that that people are generally happy with the watch, and the compliance rates are reasonably good, in the range of 80% or so, depending on the time of the day. And this kind of compliance rates are reasonably good for these watches to be used in healthcare studies. We are also looking at some technical challenges. We want to, for example, try to look at how much data gets collected, because the cost of transmitting the data from the watch can be expensive. And our goal is to look at how much aggregation and feature generation leads to reduction in data. This, for example, shows what happens if you collect data for per hour for 1 hertz, or per hertz for 2 hours. And obviously you can see that the data sizes can be pretty large, but not so large that they can not fit within the current data rates which are available by providers like Verizon and AT&T, at least in the US. But to reduce the data, we can do online feature construction on the watch itself. We collect data, for example, in this case, at a 15-second epoch, compute standard risk features for activity recognition, for example, for time domain, frequency domain, and orientation. And then we try to measure the battery life. Generally, today, we are able to get around 12 hours of battery life, which is pretty good on Apple. The Samsung numbers are a little lower, more like 8 to 10 hours. But we are obviously constantly optimizing, and our expectation is that as these smartwatches progress over time, that their battery life is going to increase because of new battery technology and processor technology both. We want to be able to also detect, for example, what times a person is wearing the watch. So, for example, if a person is not wearing it, or if the person is inactive, for example, then we can collect data at a lower rate, more adaptively, to be able to save battery life. So there are a variety of these things which we do in terms of being able to collect data. Our end goal, obviously, is that we have developed a successful system using smartwatches. And our goal is to be able to do a variety of healthcare studies in terms of movement phenotyping, where we want to be able to understand movement signatures to detect behaviors. We are looking at salutogenesis in terms of trying to collect data before and after events to be able to restore health better. We also want to be able to collect data at a larger scale to understand from a precision public health perspective on what factors like behavior, social and environmental factors integrate with physiology, behaviors, and our psychosocial well-being. And the key part is that because of the fact that the watch can collect data all the time continuously from a large number of patients, allows us to collect data outside the medical system, which we believe will in the long run lead to better prediction of intervening health events, as well as help in improving patient care. Thank you so much. If you have any questions, please feel free to send me a mail. My email is sanjayranka@gmail.com, sanjayranka@gmail.com. Thank you for listening to my talk. Thank you.